All right, thanks for coming, everybody. This panel, we're going to be talking about large-scale stream processing with an emphasis towards production systems and the kinds of issues you run into if you want to do things at large scale. Scale, for our purposes here, is going to be along a few different dimensions. One is going to be the way we often think of it, which is computational scale or the size of problems, message rates, those sorts of things, computational scale in that sense. But also we want to talk about scale in terms of supporting lots of users. As many of the people up here are involved with creating platforms for other people in their company to use, and so there's a large diversity of people that want to take advantage of stream processing. So that's sort of the other element of scale. To start, I think we should just have everybody introduce themselves and maybe a little bit of their background and why they're here today, what sort of experience with stream processing they've had, and like what maybe projects they're up to currently. Maybe start with Ted.
Well, I've been introduced.
Sure.
One of the first big projects I worked on was a medical instrument where we measured lung function in a streaming way, processed it, and sent it over a telecommunications process. And after that, it was a little bit of work in NASA, and before that was Los Alamos, all essentially streaming data without the benefit of the frameworks that did it well. So a long history of frustration on that account.
Hi, I'm Xiao Wei. I'm Senior Director in Alibaba. Before joining Alibaba, I worked at Facebook and Microsoft. Currently, we are using Flink to do search and recommendation. We also use it to do machine learning at very large scale.
Oh, yeah, and you guys have a mic as well.
My name is Maxim Fetiv, and I spent 7.5 years at Amazon, where I was responsible for building Amazon backend messaging infrastructure. And also my implementation powers SQS service. And also I was tech lead for simple workflow service. Then I spent some time at Google in the data processing and applications group, which is kind of owns a lot of big data products, including Millwall. And currently I'm with Uber, and last year I spent time developing a messaging system practically to replace Kafka, and also was involved with projects which integrate Flink into Uber infrastructure.
Hi, I'm Manal. I'm with Netflix. I lead the stream processing team at Netflix. We're trying to process a very large number of events, upwards of 1 trillion a day, and upwards of 1.4 petabytes a day. So that's where our interest in stream processing comes in, and we've been doing it for over a couple years now, trying to get a system running for the rest of Netflix engineers. In the past, like on and off for about 7 to 8 years in total, I've built streaming systems in one form or the other with complex event processing mixed in.
Okay, and I'll just introduce myself quickly too. I'm Jamie Greer. I work for Data Artisans, the Director of Applications Engineering there, which basically means I spend a lot of my time helping people get into production with Flink. That's my primary mission, is to support people in that way. I have a little bit of background in stream processing as well. I was on the streaming computation team at Twitter before I joined Data Artisans. And before that, I built a stream processing system like Ted, before any of these frameworks existed at a company called GNIP. And before that, I was kind of doing high-speed video processing. So it's kind of been a theme in my career as well. Okay, so for the rest of we just want to get like a discussion going here. I have a bunch of questions, but we can take this wherever we want to, talk about whatever's interesting. But to get started, I think it'd be good to have a little insight maybe. It's like, there's obviously this interest in stream processing these days, and if you go to the big data conferences, it's a lot more talk about it, and there's obviously a lot going on all of a sudden. Why do you guys think that is? Like, what's driving that at your own companies, or any insights, just industry at large? Like, why this interest in the last year or so in stream processing?
Well, I'll pin down one end of the discussion. I think there's been a major change in business practice, which makes day by day, hour by hour processing much less acceptable. And that people insist that business now occurs with a physicality, and the physical world doesn't happen in batches. So I think that's been one big change.
I think there always was desire to actually process, like stream processing was around for a long time, right?
Yeah.
I think recently, first the technology caught up to high rates and like really big data, and also I think I now understand better how to deal with out of order and late arriving events. Because if you look at the products which were around for a long time, they actually they're very well defined mathematically, but every time you throw a late event at them, they just weren't up to the task. And most of the systems I've seen, they either didn't use stream processing, they just used databases and listened on queues to actually deal with those, or they just didn't use really streaming engines. And I think what we are seeing now is model introduced by Millville and also right now by Flink and others, is that we actually can deal with dirty data and out of order data. And then you actually can start using these systems for real applications, and because real data is always dirty and out of order.
Yep.
Most of the applications, even if you squint hard enough and look, there's a bit of stream processing in it. And historically, it's a point solution. Developers just put in something in their app that's custom built to handle those events. And up until now, the quantity of those events or the scale of events has been smaller. But recently, we see a lot more data being produced, and with businesses wanting to extract more value or make those computations easier, whether it's efficiency of human capital or just the hardware they're running on. I think now there's a trend or realization that you need to be a little more formal about how you categorize the system, what kind of model do you use to represent solutions around it, and how do you deploy them, how do you scale them to a large deployment. So I think all those factors kind of have piqued interest in stream processing, in my opinion.
I add something. I think the current revolution in machine learning and AI also is a big force in driving this adoption in streaming. We have noticed using streaming to do real-time online machine learning gave us much better algorithm than offline algorithm would give. So this has fueled the.
Yep. It seems something I've seen is that a lot of companies that are doing batch processing already, and they have been for years now, a lot of it is actually still, we've talked about it a couple times already probably at this conference, but a lot of it is actually, it's all continuously produced data. And the fact that we've been executing using batch computation in order to sort of do analytics on this data or whatever else seems to be an artifact of the technology as opposed to the nature of the data. So I wonder, have you guys seen that the stream processing model just fits the reality of the problems that you have at your company better than before? And is it that now stream processing, it seems maybe is becoming more important, not because the problems are new, but the technology is there that allows us to actually take advantage of it. So it's a more natural fit. Is that, have you guys seen that that's the case? In other words, is the stream processing model a better approach to things that we're currently doing with repeated scheduled batch jobs?
Well, business typically is expressed in a series of transactions.
Yeah.
And handling those in order as much as possible, dealing with late events, but essentially considering them a stream is a much more natural way to deal with things.
Yeah.
And I think that people have very often implemented the poor man's stream processing with batch schedulers, and it's been hideous.
Right.
That could have been just much more simple if you had an intermittently running streaming program.
Right.
That would have been just enormously simpler.
Yeah.
And so it would have been a much more natural implementation. But I would challenge here about this idea that machine learning is more natural in streaming, because an awful lot of algorithms are inherently offline for training, and those are very, very important ones right now. Would you say that those really aren't important, or?
These are important. What happened is in the past few years, we have already tried all these offline algorithms, and they already gave us some good benefit. by tuning certain algorithms online, we see some additional benefit. Because, for example, the user's behavior may actually change from day to day, especially on some special day, like for US, it would be Thanksgiving Day sale, and for China, it's the Singles Day, when everything is 50% off. The user's behavior is very different from what it used to be. So if you can react quickly to such behavior changes, it will give a much better benefit in your algorithm.
So that isn't necessarily better results, it's just quicker results.
Yeah. But business-wise, it's better in that sense. And as to Jamie's question, I think one important thing is we do need batch processing, but a lot of times we actually need both. What Flink gave us is a unified way to do both batch processing and streaming processing, and hopefully it can also allow us to write the thing once and get both.
Yeah, so several of the people up here are involved in some way. They're putting Flink into production or they're experimenting with it. I know Xiaowei and Alibaba, you are very much using both the streaming side and the batch side.
That's right.
Yeah, are the other companies here also considering Flink for batch processing, or is it more focused on the streaming side?
So I think before coming back to it, I'd just like to address one more question before. So when we talk about streaming and batch, I think what we collude is it's the type of processing that we're doing. It's not the nature of the data, right? So you can have bounded data, which we usually associate with batch and interchangeably use it. Or there's just a large stream of data that's flowing in, and we say, oh, that's streaming. But in fact, it's to delineate their terms, it's very important to realize what's happening, right? So you could say it's unbounded data or bounded data. I'm going to process it in a streaming fashion or a batch fashion.
Yeah.
And you can do both in both fashions. Then it depends on how fast you want the results, how accurate you want the results. Do you want a Lambda architecture or like a copper architecture and just do it streaming or not?
Yep.
So I think making that differentiation first makes it easier to have the rest of the conversations. Coming back to having both systems, I think a lot of companies that have been data-driven before capable stream processing engines were around,
right.
They already have a big installation of either Hadoop or the existing batch technologies, and they're already delivering certain value. So replacing those with stream, or there are certain aspects around like machine learning, and you need a better model versus a quicker model. So there'll always be kind of a need for batch until we figure out a way to do everything online. That may or may not happen depending on several factors. And if you have a very, very large data set and you want accurate results, you don't care about getting it right now, the expense of doing it right now may not justify it. But on the flip side, there may be more and more algorithms that could get online, and you could serve them with stream processing and get good enough results fast that then you don't have to put all that stuff into batch and pay the cost there.
Yep.
So I guess it's a balance, at least for a short period of time.
Yep.
Until we figure out.
Actually, I like to point out very often that real time can be much easier than batch. If you're processing in real time, you have 3 years to process the last 3 years' data. If you do it in batch, you may have 5 minutes. So real time as it has, you get to start early.
Yeah. It's just the kind of like workloads. Like if you want an accurate machine learning model over 9 months of data, and you don't have existing algorithms that have been proven for online, then doing in a batch style processing would be great. And you could do that batch processing with a streaming engine. There's nothing stopping that. So that's why delineating those things makes it easier to have a conversation.
Yeah, I wonder, I know, and kind of the Beam folks have really tried to push this idea, and I think we should probably start to try to adopt these terms, right?
Yeah.
Talk about bounded and unbounded data sets and streaming and batch execution as two separate things, right? I think that does make the conversation a little bit easier.
So I think there's 2 great articles by Tyler on O'Reilly. If somebody wants a baseline terminology, to start talking about stream processing, that's a great resource.
Yeah.
Thanks for pointing that out.
So just a little point about performance is that I found that in a lot of cases, like batch jobs, for example, called services, like microservices, right? It's not just computation. And in some cases, batch jobs, they just tend to call the services in very kind of non-distributed, like distributed by time way. So, okay, you call during 1 hour, you get 1 million calls, then you just don't do anything, for example. Mm-hmm. And for microservices, actually, for scaling of them is actually not very good. So I've seen people migrating to online processing and just getting much better performance and utilization of their services, just doing that. Obviously, there are other benefits of doing online, and there's obviously the speed, but just utilization of their microservices is a big deal for a lot of use cases.
Interesting. Okay, so I wanted to cover this next topic. So something that's sort of new in the last year or two is really thinking about stream processors and state. So we're really emphasizing, one of the things that's changed, the reason we can do a lot of the stuff maybe we were trying to do in batch before, or we can really try to do robust computation in real time, is that the stream processors now have state capabilities. But what challenges trying to do this at scale and for a large user base of diverse sort of applications? What are the unique challenges of stateful stream processing, and have you guys already run into some things, or have you thought about this problem? I mean, how have things changed with this fact that we have stateful computation now?
Stateful is not new. Just stateful done well within a single framework is relatively new.
Yeah.
And I think that the big problems that we have are exactly where the boundaries of that framework are. So if you have state in Flink, you're not so bad off. But if you have state that exceeds the capacity of Flink to manage, and it has to be stored in some sort of persistent way, then you have a much harder problem. And trying to keep that exactly correct is a much more difficult problem that hasn't been solved by the purely inside type solutions yet. Well, we've been doing that for years, and some people do it very poorly for years. But it isn't like it's an entirely new problem or without any solutions. It's just that the solutions have gotten much better.
Right. Yeah, we should probably add the new capability is consistent state. State that's consistent with the stream processor, or with the stream, the input stream. That's the sort of new thing, I think.
Yeah, I think adding state into the stream processor is a big revolution. It greatly enhanced the amount of features a stream processor can do. We recently have moved some online machine learning job to Flink using its state, and greatly reduced the amount of access we will need for our edge base. So the QPS to our edge base just chopped. It's greatly improved the efficiency of our whole job, but managing state is difficult. We also have quite a few challenges. The first one is to handle large amount of state. It's critical to have incremental checkpoint, which we did in Flink, and the Flink community is also working on that. And the second part is when we have a state and when failover happens, especially in exactly one scenario, we would need to rewind a large portion of the job graph. This recovery can be pretty slow. Even though this does not happen very often, but for mission critical job, it's still a big deal. That's one area we still need to work on. And the next thing is, just as Ted pointed out, it's currently not possible to move all the states that's in HBase to Flink yet. Because, for example, if the state is private to an operator, it's pretty easy to do. But sometimes a state is not only accessed by a single operator. It may need to be accessed by other operators in the same job, or it may even need to be accessed by operators from a different job. How do we incorporate it in Flink and give the consistency guarantee is pretty difficult.
Yeah.
in my experience is that actually state is one of the main reasons why people don't use streaming systems. They prefer databases and queues, for example, to implement similar functionality or triggers. If some databases support triggers.
Right.
So having state inside of the streaming system, and especially if it's fully transactional, certainly is a big deal. But at the same time, currently, and there are some ideas how to fix that, but limit on the size is very important. I think for us, unless we can ensure that we can store practically unlimited amount of data, having that current work set, like active work set is limited, is very important. And other part is migration. For me, is databases, they have well-defined schemas. When you migrate from one version of your software to another, you can define that. Right now, the store in Flink is very rudimentary. So if you accumulate a lot of state and very important business state, and then you need to upgrade your pipeline, and there is no like real guarantee that you will not lose that state at this point. I think it's, for me, the upgrade story is the most important one. Right now, practically, at least when we design systems, we always assume that they will be backfill, that you can always lose your state and reconstruct that, but it's not always possible in all business scenarios.
I would actually classify shared state between jobs as a bug, not a feature to be worked on, but a misfeature for it to be stamped out. What do you think?
Yeah, so I don't know how it would work, but we did notice when we changed the state, wallet state move some data from HBase to Flink, it greatly improved the throughput of our whole system. So I do not know the correct solution, but I want a solution that can give us a similar kind of benefit. It may not be necessarily transferred to a state in Flink.
I think for us, with respect to state, it started out small, having folks have a smaller need of state, but then it certainly grows because when you give tooling like that to people, they realize what else they can do with it.
Right.
And with that functionality, there are a few challenges that arise, right? One is, I think state needs to be made first class. What I mean by that is, when state is stored, when state is replicated, when state is accessed, it should not be tied to the stream processing engine that's running it. And that kind of ties back to being able to upgrade across versions or being able to build tooling around to see exactly what's happening inside your state. And the other thing is around fault tolerance and very fast recovery. So if you have state and you have certain machines fail, and in an environment like Amazon Cloud where we are 100% in, failures are really common. They happen all the time. So being able to quickly recover regardless of the size of the state is important as well. So I think for us, three broad areas where we could really see enhancements or advancements to Flink could be the incremental checkpointing that we heard about, the hot standby, and more tooling around state so that we can expose it back to our users as to what they're storing, which operator is storing what state, and at any point in time, they should be able to dig in and see what's happening. And that could either be by external tooling or just making the queryable state more enhanced so that you can not only query the state, but also the metadata around it. Like you have window operators, what kind of windowing it's doing, what state it is actively storing. So it helps with debugging as well. So for us, I think the challenge is around those three areas.
Yeah. Yeah, so one of the ideas that's floating around, it's just, this is all sort of forward-looking, but we're talking about and thinking about in the Flink community whether or not we should bring in more sort of simplified but database-like capabilities into the stream processor. So there's this idea, Stefan talked about very large state. You just mentioned some of the same stuff that enables very large state and the ability to query that state. In general, I mean, the people on this panel, we sort of have this decision to make about whether or not this makes sense. I mean, does it make sense to bring these capabilities into the stream processor? Or should we find a way to work with a more traditional external database, but have it maybe participate in the checkback and, or sorry, the checkpoint and sort of recovery mechanism in Flink in a consistent way, because those seem to be our two choices in a sense, right? You could potentially have an external data store that could participate in this checkpoint model with Flink and could roll back consistently in the case of failure, in the same way that we do with Flink state. So I don't know, we're kind of at this point where we could start to do this in the stream processor, or we could decide not to. Does anyone have any input on that?
I think the throughput, the ingest rate, is going to make it very hard to use any existing engine, which is not usually designed for very high ingest rates during checkpointing. And so I think you're going to wind up spending more effort than just providing basic access. Most of the state, queryable state, is write mini and read almost never on average. And that's one of the worst things possible for conventional data stores. They find it expensive to ingest data and relatively cheap to read it.
Yep.
And so it's just upside down. You're going to wind up building something that's at least as complicated as Flink in order to do that participatory checkpointing, I think.
Interesting.
I think the man over there has an opinion.
I'm not sure I fully agree with that. First, we are already using database underneath Flink, right? And Flink didn't implement the database, it's just local. Is it RocksDB, right?
Yeah, it's just,
so it's database. For me, ideal solution would be remote database which supports snapshots. I'm not aware about anything but Spanner, which supports snapshots out of the box, but I don't think there is any open source solution for that. But for me, ideal solution would be something like Cassandra, which supports snapshots. And I think it's possible to implement, mostly because, again, you don't need to do pure key transactions. You just need to write all your keys and then say, this is the snapshot, and I should be able to recover it. And not every use case requires very high write rate. And also, we need to write only snapshots. So if you modify a single key 1,000 times and you checkpoint every snapshot every minute, you need to do one write per key per minute. So if you have very counters and some operators which are very high update rate, it certainly helps. But yes, I don't know about any database which provides snapshotting out of the box. We have some ideas how to implement it on top of Cassandra, but it's certainly more like workarounds than native solution. But I think Flink is good in what it's doing and just doing stream processing, and I would prefer to have separate kind of database which does what it does well, like storing data.
I think having a lightweight solution as part of Flink would help. It doesn't have to be a complete implementation like Cassandra, but currently the local state's backed by RocksDB, and if you're able to just efficiently replicate that, and it could be a short window, you don't have to hold all the state to be really effective, then when you have smaller failure windows, then you can at least recover from those failure windows really fast. I worked on a system called Dynamite in Netflix a couple years back. It's still active, where we built a Cassandra-type sharded layer on top of existing databases. So it may be a little challenging, but I don't think it's as complex as building another Flink layer on top, because we're just talking about a light layer that makes it easy for faster state recovery.
I think there are data from different categories. There are data that's purely private to a single operator. In that case, it's probably best to keep the data in state. There are cases like the data is really shared by a lot of other things, even to some other service which is not Flink jobs. For such data, it may make sense to be stored in some traditional database system. But for data that's more private, I think if we can support it in Flink as stated, it will be greatly beneficial. So it includes data that's private to a single operator and data that's private to a job. I think it's not like we should do one or the other. It's best if we can support both and offer option for our users so they can choose depending on their scenario. Another point I would like to add is the way Flink handles data in its checkpoint mechanism has a lot of spatial characteristics that's different from traditional database. it would be nice if we can have a database system that can leverage such properties and be more efficient.
I think there was a transmutation of the question as it circled around. I was answering whether or not we could externalize the queryable state, which means in the moment with the exact value. And I think Andreas was answering the question, can you externalize the checkpointed state, which of course does update much less often and is much less useful to query, except in the case of restoring to failure.
Yep.
So it's really two different questions there.
That's true, yeah.
I think that the queryable state is going to be very hard to externalize.
Yep, right.
I think just one more note added to that, what Xiaowei said. It may be beneficial to add support to be able to choose whether you want it in a local store or external, because then you can have a slow-changing data or one that's accumulating state can leverage the existing database deployment most companies have.
Right. Yeah, I mean, I guess it's a pretty good point, as Ted said, that the queryable state, externalizing that kind of in the moment is going to be difficult to do without local state, right? Flink state. Yeah. Did you have something else to add, Maxim? No. Okay. Let's switch topics a little bit while we still have a little bit of time. One of the things that I know everyone's interested in is bringing sort of the power of stream processing to a lot of user groups in their companies. And there are several different ways you could sort of expose a programming model for stream processing to various groups. Have you guys thought about, and do you have opinions about what the right model for stream processing is in terms of like a programming model? So is it SQL? Is it some lightweight DSL? Is it something else entirely? What do the users that you're familiar with in your respective companies seem to want?
Well, I don't think it's just users. I think it's problems that speak as well. And so I think it cannot just be SQL, any more than data processing can just be SQL. SQL is a very limited language in many ways and just can't express everything that's needed.
Yep.
So, partial answer, it can't just be SQL.
Yep.
I think I agree with what Ted said. I think SQL probably solves 80% of the long tail problem. It's good enough for most people's use. But for the 20% of users, they have a lot of spatial needs that simply cannot be satisfied by SQL, and they may need an API at the operator layer.
I think there's a SQL and like just code. They're used by different like different people at the company, right? So, for example, at Uber, we have a lot of very non-technical users who actually, like in every city, there is a team which operates the city. And there are some SQL interfaces that already exist in the analytical data sources. And these people, they actually innovate independently from software engineers, just using the SQL knowledge. And they actually implement a lot of business processes without involving engineers, just because they have access to SQL. So giving them SQL interface to streaming would certainly enable a lot of innovation, like much faster innovation. But they're not technical enough to write. And also there is the whole deployment and kind of code development complexity, which these people don't want to deal with. At the same time, there are use cases which you just cannot implement in SQL, especially when you come up with custom triggers and complex windowing logic. It just SQL is not the right technology for that. So those use cases can be solved only by engineers and require a lot of kind of thinking and coding. So for me, these are kind of, we need both, and they just solve different use cases.
Would you say that the 80% that he talked about is kind of like the 5x bigger audience that you're talking about? Are they the same number?
I don't think it's about numbers. It's certainly, if you look at number of queries, it would be more than 5x. So if you start looking at, because every city can have a little bit different query, for example, based on their requirements. Because legal framework is different, the marketing, it's just different, like different business. So that's why they actually need to adjust these queries. And writing code to kind of satisfy all of them is almost impossible.
Based on the use cases that either people have today or want to build at Netflix, and maybe analyze those, we found a whole range of what people wanted to do with stream processing. And it's the whole spectrum from someone saying, I just want to do simple counts across a certain window, and then I just want you guys to take care of the whole infrastructure, resilient state, I don't want to worry about it, just tell me if my job's working fine, to somebody doing completely custom implementation on it. And on both the spectrum, on one spectrum, you need to know all the nuances of stream processing, right? You need to be aware of the windowing, the triggers, how do you handle late data, how do you handle completeness of data with watermarks, how does those work? So there's a bit of a learning curve to do that, but it may be worthwhile for somebody who really wants to fully leverage it. So for us, for that reason, we see a need for an API or a DSL that's simple enough, and at the same time be open to somebody who wants a fully customized solution on the platform. So we have a large set of use cases, like our pipeline itself is declarative with people defining what their filtering rules are and what kind of basic projection they want or how they want the data to be indexed in Elasticsearch. That's one use case where all they need is a simple DSL, and something like SQL would just work fine. And we have other use cases that are much more complicated that they want to do custom dynamic session windowing on events that are happening either by the users or within our infrastructure. And there they don't mind spending the time to learn and understand the stream processing model and deal with it. So for us, I think it's a spectrum. And being able to even expose that, from a Flink perspective, whether it's documentation or saying, okay, if you want to do something that's simple, here's the API to use, and then you can progressively go more into depth of it and leverage the API even more. So I think having that spectrum of functionality reflect in the API and usability as well, we find that to be very important for us for adoption of the infrastructure.
Just one little point. I found that in other domains as well is that you want a mixed model very frequently. For example, you get data. Data is usually dirty. It needs to be cleaned up. It needs to be kind of make sure validated and so on. Those type of pipelines practically impossible to write in SQL. You want engineers actually write clean up, for example, or just like manage the data to the point. Then somebody can go and use SQL, for example, to process it. And then maybe if they produce some results, then use of those results also requires some more custom pipelines because maybe you want email notification or more complex processing of that. So I found that, for example, engineers writing pipeline which has some pluggable points when you can write, for example, SQL is in a lot of cases is the best solution versus like just completely custom pipeline versus completely SQL-based pipeline.
Yeah, I think that makes sense too. Like this notion of sort of like curated streams seems to be coming up again and again in different companies. We can. I think I wasn't sure if we wanted to do that, but we could take some now. I suppose. Yeah.
It's just difficult to see the audience.
Yeah. Yeah, there were a few hands at the end of the keynote, though, too, right? So.
This thing on? Yeah. So at the very beginning, there was a discussion about what was actually the thing that started to bring stream processing to be more adopted and so on. And I think there were mostly 2 points raised by different people. One was the idea to properly model event time out of order, and the other one was that the stream processor technology matured enough to actually handle volumes that previously only the batch processors handled and so on. I'd be curious which of those 2 points would you say is the one that for each of the candidates, which of those 2 points, like first of all the performance of the stream processors getting better, the accuracy, actually doing high throughput on exactly once, or being able to model out of order streams and event time, which one was the more important one, or do they just so strictly go together? It had to be both of them. Either one of them alone couldn't have done it.
I see it as accommodation, but with prioritization. Performance had to be there. And for some applications, correctness doesn't much matter. Look at Bitly. And so getting the performance up allowed some applications to start and started the revolution. but then the accuracy had to be there to extend it further.
And the situation is similar here. I think the performance is a critical thing. It used to be, things used to be not possible become possible. That's the most critical part.
Also, if you look at most complex event processing engines and streaming engines from the past, they are mostly single process. I'm not sure if like probably 10 years ago, most of them were just single process. Yes, they could perform a lot of operations per second, but they couldn't scale out. And I think something like Flink, because uses ideas from MapReduce, and based on those ideas, you can actually scale out job almost infinitely.
So I think, again, high availability and performance, it starts out with that you're able to efficiently and predictably and in a highly available fashion, you're able to get the events in, you're able to route the events to the right sinks, and maybe offer a little bit of enhancements to the events. It starts out like that, and then once people realize the kind of events that are flowing through, and they have a stable pipeline, then they start looking into how can we leverage the data more. And that's where having a good stream processing system kind of helps. If it's easier to use, if it's easier to reason about, then you can gain more out of it. So I think in that order.
I think also the success of MapReduce helped because a lot of companies started to actually look into the big data and use big data because of MapReduce, and then they needed more real time. And before it wasn't about big data, right? It was about something else.
Yeah. Do we have other questions in the audience? It is hard to see.
They've got this wonderful pillow with the microphone.
Yeah.
And you can actually throw it from person to person. So it's almost worth asking a question just so somebody will throw you a pillow.
I guess we should have had some swag.
Yeah. Oh, yeah.
Good catch.
Hello. I want to go back to the external, the idea of external state, because it's extremely interesting to me. It seems to me there's the kind of state that kind of needs to be maintained in order for Flink to do what it's doing. You know, maintaining like, you know, a table of moving averages or something like that. But there's also state which kind of inherently lives outside of Flink, like, you know, the customer orders table or something that the Flink process nevertheless needs to access in order to do its stuff. You know, that's not going away. I mean, that's large state. It's too large to get into Flink, but nevertheless we need to access it efficiently. So, I mean, it seems to me that kind of quite a lot of kind of re-architecture could be done so that we can access that external state in a way that doesn't require a network round trip every time we need to go to the database. And so if the external state is in a system like HBase, for example, you kind of need to intertwine Flink and HBase in a very kind of complex way so that the data is flowing through the precise HBase nodes where the data happens to live. Do other people see kind of improvements needed in the way external state is managed in that kind of way?
So I think the first need we have is usually around joining with existing data that's either slow changing or it's in an external store, right? So it might be some kind of a lookup table that is updated based on what you're stream processing, but it needs to be, again, joined back in. So the idea of like side inputs, right, to get an additional information, a piece of information from a remote data store that you can join in with your stream is important.
Okay, let's take the pissant defiant view here, that side table that you look things up in shouldn't even be a table. It should be a stream of updates that's reified inside a microservice instead of a table that's shared.
I think first in production, we see a lot of cases just as he talked about. in any complex streaming job, we do need to access external state. In some cases, external state can be internalized as a Flink state, as Ted was suggesting, for example, treating as an update of strings. But in certain cases, this may not be the best way because this state may also need to be accessed by other services. And currently, even with the queryable state, it doesn't have a high availability. So this limited choice. Another point is by moving state from external database system to internal Flink state, the performance does give us a big performance boost. So the more choice we have in this space, the better. And in case that we do have to access external state, we recently added a new feature called async I/O support, which allow us to access external storage systems using asynchronously. This so your operator will never be waiting, and you don't need to waste a lot of threads just waiting for external storage. This greatly improves the performance. But I think it's extremely fascinating, interesting question to me, how much more support Flink can have in its state. For example, if Flink can allow the state to be accessed by some other operators within the same job, this kind of simulates the notion of iteration in streaming. But this is just very preliminary result. I haven't figured out exactly how we do it in a consistent way.
In 5 years' time, is Flink going to be the database? Is that where we're headed? Is Flink going to become the database? If those reified, event histories that Ted talks about become the place that all other applications go to find the data, Flink has become a database, right? Is that where we're headed?
I think for Flink to become a database, you need to do a few things like HA, such kind of things. So first one, with queryable state, how do we make it always available, even in the case of failover? Second, when it becomes a database, do we allow updates from other systems rather than your current job? This state may not be private to your own. So I think there are lots. This is an extremely interesting question, but there are lots of investigations that need to be done before we can answer that.
So I personally think that it's not like database, but yes, it becomes more like service, which can serve data and serve consistent transactional data. In terms of external data sources, as in for the Batuber, you never access external data source directly. You always call through service API because every data source is wrapped in a microservice. So practically in our world, and it's not even data. For example, most basic one is that location of a car. If you want to know that something happened in a given city, you give a GPS coordinate, and there is a service which actually deals with mapping these coordinates to like appropriate physical locations. So it's a service. So it's not even like database lookup, and there is no way around that. And Flink doesn't have good support for calling services out there because, for example, if it's a synchronous call, right now, operator, practically, you will put that operator, and there are not even different types of slots right now. Yeah. So if I need 10,000 of those, because, for example, my synchronous call is slow, there is no good support for that. I think asynchronous calls could help, but we need to practically implement ourselves some sort of batching calls, asynchronous calls. There is no clear way to call services right now, which have high latency from the Flink job.
So I think if the question was around in 5 years, would we just have a stream processor with state that looks like a database and not even maintain a database? But I don't think so, because you'll always have state that's really important to your business, but it's not very frequently accessed or may not be needed all the time. So you still need a database to park that state. And the state you'd have in your stream processor is the one that's needed to do the analysis, or even if it morphs into stream processing being another pattern for building applications, you'd still only want the state that you needed right then. And I think there'll still be a need for an external data store.
Yeah. I think we're definitely out of time here. So I guess I want to thank these guys for coming. All these people have traveled from all over the world to be here. So thanks for being here, guys. And I think we'll wrap it up here.
Thank you.